Right, so two unknowns that we're looking for. This time outside angle A is the angle that we're interested in. So we can start with the easier part. How can we find the value of f, in this case, hypotenuse, or the magnitude of this, what will be a vector when we get to that part? Right, we can use Pythagorean theorem because it is a right triangle here. So it will be the square root of the sum of the squares of the legs, 4 and 11. And to 2 decimals for this triangle, we get 11.7 newtons as that answer. 11 newtons, 4 newtons. Our hypotenuse also has the value of newtons associated with it. All right, so that's straightforward enough. In this case, we want this angle measured from what we will be usually calling the positive x-axis. So how can we find that angle A given the information that we have, or what process do we need to go through? Right, so the easiest thing to do is, because we formed this triangle, we can find the inside angle easily using arctangent or arcsine or whatever we want to use there. And then what we know is from the picture, A and what I'm going to call beta here are supplementary angles, meaning they sum to 180. So if we know the value of beta, we can then find the value of A easily by subtracting beta from 180. So the first thing we can do is find the value for beta then. Using our triangle rules like before, probably the easiest thing to do is to find the arctangent of the opposite over the adjacent. So 4 over 11 gives us that the inside angle here is 20 degrees. Again, with the knowledge that beta, as we drew it, and A are supplementary, then if we take 180 minus the beta, that's going to give us the value A that ultimately we're interested in this problem. So in that case, the 180 minus 20 tells us that A is 160 degrees to this construction line, which I'll call right now the positive x-axis.